So hello everyone. So today I'm going to be showing you how to use a potentiometer in a simple Arduino project that I just came up with. So this is a Arduino project which uses which I use a potentiometer to change the contrast for a LED light. So as you can see, I'm turning the knob, and then if I turn the knob that way or counterclockwise, the light gets dimmer. If I turn it clockwise, it gets brighter like that. So it's a little bit different than the other project that I did using, or test that I did using a LED light, just like switching it on and off. This allows you to like change the brightness of the light. So this is a little more interesting, and I'll put the diagram of this and how you can plug it in and everything, how you can set it up on the next diagram. So I'm going to show you that. So okay, here's the diagram for the Arduino Uno with the potentiometer. So this is a Arduino Uno. I'm using a ELEGOO Uno, so it's pretty much the same thing. So basically, here's the potentiometer. You just connect it like that. You just put in the pins like that, and then this one in the middle goes into across the trench. And that's how you put it in. Make sure it's firmly in there. And this light green line pin goes into the 5 volts, and this orange pin goes into ground. So you could set up a kind of like a strip thing. You could use the positive and negative thing, but since we have enough ground pins in the Arduino Uno, we're just gonna use the ground pins in the Arduino Uno instead of using a strip. So that's why I'm doing this today, like this way. So next thing you have is the resistor. This is a 220 ohm resistor, and this leg right here, I'm going to put it into number 5, analogRead 5, and I forgot about this light blue one. The light blue one that goes into this pin goes into A0, or analog 0. This is for analog, so a potentiometer uses analog. That's why you could kind of like you could use a knob to adjust it. You can't do that with digital. So you could use any of these analog in pins, but I'm just using A0. If you want to use A5, you could, or A2, or A3, A4. That's fine as well. But you have to put that into the coding when you set it up. So the next thing is the 220 ohm resistor. It goes in right here with this line right here. It goes into pin number 5. So I just put it in pin number 5. You could put it into pin number 6. You could put it into pin number 3. It doesn't matter. But I just put it into pin number 5. And in this leg of the resistor is connected to the LED, the long leg of the LED, and I think that's a positive, and the shorter leg is negative or ground. So this one is connected here with the yellow thing. You connect this LED long leg into here, and the short leg, I just connected it here, and this goes into ground. You could put it here, or you could put it into this ground. It doesn't really matter, but I just put it in there. And as for this thing right here, you have to draw a linear graph and find out what the equation is for this thing before you do any of the coding. And the potentiate, you have this y-axis, and the maximum value for the y-axis I set Y to LED value. So when it's at 0, 0, when it's at 0, it's also at 0. Everything's at 0. And the maximum value of Y is 255. So 0 is X and comma Y. So Y is 255. So 255 is the highest for the Y axis or the vertical axis. And for the horizontal line is the X axis. And the maximum value for the potentiometer is 1023. That's just what it is, and the maximum value of the LED is 255. So you just have to know that, basically. And when it goes to this axis right here, so this is it's 1023 comma 0. So the X and Y, like I said, is like 1023 is X and Y is 0, so that's what it is here. But when we get both, the maximum of both values, X is 1023 and Y is 255, and that's how we set it up. This is basically the slope of the graph, and we need to figure out what the slope of the graph is. So in algebra you learned how to find the slope of the graph, and that's Y final minus Y initial is equal to M, which is a slope, parentheses, X1 or X final is minus X initial. So here it's M, so we just solve for M. M is equal to Y1, Y initial minus Y final, Y initial, divided by X1, parentheses X1 minus X0. So here, or so we could say the LED value 1 here is minus LED value 0 here, divided by the potential value 1023 is minus 0. And this is what we get. So M is equal to 255, which is right there, minus 0, divided by this is the maximum value of X, 1000 of the potentiometer value, 1023, minus 0, right here. And that's what we get. That's a slope. So therefore the slope is equal to 255 divided by 1023. So an X. So the equation of a linear graph is Y equals mx plus b. So b is 0 because it starts at 0. So if it started at 5, then it would be 255 divided by 1023x plus 5. But we're not starting at 5, we're starting at 0. So therefore it's y is equal to 255 divided by 1023x. And that's the equation of the line, basically. And the next thing is I want to go to the code. And I'll explain this to you very clearly. So in relation to the diagram, so this is a integer, so we just declare all our variables here. So int is potpin is A0, which is right here. This is what we're reading in from the potentiometer, and the initial or integer LED pin 5 is basically for the LED, and which is right here, number 5. And int potential value is basically that's a potentiometer value, basically. So A0 is here. This is where it's being read. And int potential value and float value for this is what we want to find out. So LED value. So pinMode is, now we set it up. Potpin is an input. Like this A0 is an input. pinMode and LED pin is an output. Basically, this is what we want the color to change, right? To the full brightness to dimming it down when it goes to 0. So 255 would be on all the way, and 0 would be all the way down when we turn the knob. And this is a baud rate. I set it at 9600 baud. I think you could change it to whatever you want, but I found this to be more stable. So this is a potential value is equal to analogRead potpin. So we're reading it from here basically. So LED value is equal to what we had before, the slope, which was right here. We found 255 divided by 1023. And LED value is a float. Float point means number with decimal. So let's say you divide let's say we divide 10 divided by 2. That would be an integer number. But we don't always get integer number. Let's say 10 divided by 3. That would be a float point number with decimal. That's basically what it is, a float point. And we go to LED value. This is the equation. Is equal to 255. Point, we put a decimal because it's showing that it's a float point, divided by 1023. Point, which is also a float point, times the potential value. This is what is being read, right? So let's say the potential value was let's say it was half of it or something. Okay, so it'd be 1023 divided by 2, so that'd be 511.5, right? For the potential value, that's how it would be read. It'd be times 255 divided by 1023, and we would get the value of 127.5 for the LED value, and the dim would be, and the light would be half full basically. So next thing is analogWrite, and this is the LED pin. This is what's being written out, the LED pin, which is pin 5, and the LED value is the number that we get here basically. So if I said it was half, light was half dim, half full, then it would be this value and this value. So we would get 127 here basically. And this is Serial.println lead value. This is the number that we get for the LED value, right? So it can't be over 255. It will be anywhere from 0 to 255. So if it's at 0, then it would be off. If it's at 255, then it would be on. If it's at 127, it would be half dim. And I'm going to show you that basically in okay, right now you see the light is completely on. It's a 255. I'm going to turn the knob. Now the light's getting dimmer and dimmer. Now it's off. Switch the value. Like this. said that number was what? 127? Okay. Let's go to 127 then. That's 146. 127. Now the light is half dim. So that's how it goes. That's pretty much it. Okay, anyways, thanks for watching. My Ace 1000KS 1975 signing out.